So I'm going to explain the flow simulation over the airfoil using Ansys Discovery. So in Ansys Discovery, we cannot do the 2D simulation like a sheet-like model. We have to go for the 3D only. So I'm taking a thin slab kind of model, just a 10 centimeter, 10 mm distance I have given here, thickness I have given. So I have used Knockout 412 airfoil. So just I imported the airfoil using Excel sheet using the coordinate point, then increase the scale to 100 mm, then just around it I created one domain, then you pad it. I just done the mirror extension on both sides 5 mm, so totally 10 mm thickness. So this model only I'm going to use it for the flow simulation over the using the Ansys Discovery. But if you want to use the Ansys Discovery, you should have the graphics card, that too Quadro graphics card, then only it will run. And so this is the Ansys Discovery button. If you click, this will be the main window, it will open. So first step, I am going to import the geometry. So just 2.5D analysis airfoil I am going to import. Using the scroll button, you can zoom in, zoom out. Then by holding the scroll button, you can rotate the model, and using this view option, you can keep it in a proper orientation. So next step, I have to define all the boundary conditions. For that, you have to go to the simulation. So now rotate, then to give all the boundary conditions under the simulation, you can see this fluid flow option. So click on it, you can see all the inlet, outlet, wall, porous, fan, everything you can give. So first, this is my inlet, and inlet velocity I'm going to take it as 40 meters per second. Then rotate another side. If you see, this is my outlet, that is, if you press escape, the window will be closed. Okay, so in that case you have to once again select fluid flow. This time outlet, this will be the outlet with 0 Pascal. That means it is in the operating condition of 101325 Pascal. Atmospheric pressure only system is running, so here you have to keep it 0 Pascal. So inlet outlet is defined. Then go to the wall. I can keep this as the wall with stationary wall, or even I can keep it as a free slip, that is wall is moving with the same free stream velocity. So bottom and top, I am going to select it as a free slip. Then on both sides, I am going to give it as a symmetry. You can see the symmetry option. This is also symmetry, and this side also symmetry. Then keep it in the proper orientation. You can see airfoil is a non-slip wall. Top one is the free slip, bottom one is the free slip. This is the inlet, this is the outlet. Like that, you have given all the required boundary condition. And the fluid is the air. Everything is defined. You can minimize this window. You can press escape to clear everything. You see, once everything is properly defined, then only this green color button will come, solve button will come. If some errors are there, this button will not be enabled. Also, there is a notification. Here it will show all the errors, what are the errors it is getting. And this ring is the it will show you the progress. If the simulation is happening, there is a white color shadow which is following this ring, and this line shows steady or unsteady. Okay, steady flow or time dependent flow. If you want to run, you can choose it. Now I'll go for just a steady flow only. Okay, now you click on this solve button. Okay, it started solving it. So you can get the vector plot or contour plot or combination of these two, or only vector plot. Okay, or this isosurface or streamline pattern, or just a particle, or only this vector field like that, whichever you want you can get it, and you can save the scene also using this as a clipboard or current scheme 2D, whatever you want you can save it. And other than this contour we can check the forces also. For that you have to go to this monitor, select the variable. So everything you can find. For example, I am interested in finding the force. Select the force, then create the box, that is do the box selection of the model. Here it is airfoil. First x direction, okay, that means drag force we can see. So select, see drag force window has been created here, also separate graph. Then once again select the airfoil, this time select the y direction, that means left direction. Accept, that means that is lifted window also created. Now I can press escape, so it will be gone. So I have x and y plot also here. Okay, so already it is running, I haven't paused. So it is showing lift is 0.19, drag is 0.018. So after first time simulation, this mesh button will be enabled immediately. In the beginning itself it won't be enabled. At least one simulation, just you have to iterate it for few seconds, few iterations, then only this mesh button will come. Okay, so now click on this mesh, maybe this one you can hide it, and we are seeing the mesh in this cut section plane. Where is the cut section plane means, see this is the cut section plane, you rotate you can see this is the cut section plane, but I wanted to see the mesh in the vertical plane. So what you have to do, to rotate any plane or object etc and all, you have to go to the design, there is a move button. So select this plane, if you want you move, okay, and if you want you can rotate also. So I want to check it for the 90 degree, parallelly I have to check. Now you see, we can see the, this one I will close it, later I will open this. This is the mesh, okay, and this is the size. From the GPU it is taken 3.2. Many may have just 4 GB alone. So you see 4, almost it is taking 3.2 GB. And this side and all, I don't want this much refined one. I need refined mesh only around the airfoil. So how to control means, you see this explore fidelity. If it is pulled this way, that means very fine mesh will be generated. You see the meshing is happening. The white color shadow is moving. You see it is very fine now. Or I can make it to this extreme so that it will be very coarse. Okay, better I will keep coarse in other area. Then I can refine only on this model. Here it is airfoil. For that you have to go to simulation. Okay, in the simulation you see there is a local. So locally you can define the mesh element. Again box select, this window will come. We can enter maybe value in terms of mm, it will be easy to understandable. Mm maybe 0.1 mm for example I am giving. Okay, you see 0.1 mm. Now meshing is happening. To see that, just you can run this. Okay, so now you see the difference. This is very coarse here. Only near the airfoil it is, you can see the size preview. See here it is 3.2 outside, but on the airfoil alone I got 0.1 mm I have defined. And if you feel that outside is still it is fine, I can still coarsen it, then in that case you have to go to this global. Instead of standard one, you can go for the custom one. You see the custom value, it is showing 1. So if you want to refine it, you should give more than 1, 2, 3 etc and all. And if you want to coarsen it, then you should give less than 1. For example, twice the time. If you want to increase 50%, you want to increase from 3.2 to 6.4. If you want to increase, then I can give 0.5 here and enter. you see it has become 6.4. Further, if you want to increase also, you can increase. Okay, so previously also very coarse mesh everywhere, same 3.1 GPU. This time also you see here and all coarse, but I got very fine meshes around the airfoil, but still same GPU size is used. So this is how you can refine it locally wherever you want with the available GPU. I have around 12 GB GPU. So this is the mesh. So simulation is going on, and you can hide this mesh. Instead you can enable some other flow pattern, and this is the show chart. Already we generated the lift, drag, etc. and all. Additionally, it is showing maximum velocity pressure also. That window you can close it. See, this is how drag varied, lift varied, because I have changed this mesh condition, right? When every time when I change, it is telling what is the lift value, drag value for every different cases. So I am taking the last one as the final one. Okay, 0.15 Newton for the 0 degree and 0.0148 Newton for the drag force. This is for lift, this is for drag. And you can change the angle of attack also here itself. Again, same way. You have to go to design, you have to use this move button, select the airfoil, and this blue color, just you rotate, wait for a few seconds, that degree entering window will pop up. Okay, so first I am giving 5 degree for example, then it should be 355 and enter. This and all, to hide it, just to press escape, it will hide. See, press this mesh. Also no need of mesh. Okay, so this is how for 5 degree flow pattern varies. So I think 4 is for 0 degree I mentioned. Now 5 degree I rotated. Now you see how the CLCD varied. Even in the instantaneous forces also you can see by pressing this, you can see how lift force varied for every iteration. Previously much variation, now it has become constant. So soon it will be stopped and that value will be recorded in this chart. So you can get whichever the contour or combination of 2-3 contours, etc. You can get it. Okay, and here also, for example, vector, if you see, I can adjust the thickness, I can adjust the tail length, I can adjust the count, like that. Whichever you want, you can adjust it. You see, for 5 degree from 0.15 Newton to 0.52 Newton it is increased. And if you want, you can further rotate also. Box selection, this you rotate. This time maybe I will take 340, that means 20 degree just I will try, or 10 degree, that is 350 you will try. Okay, 10 degree first I will check. So 0 degree, 5 degree, now I am checking the 10 degree. Okay, so these images and all, if you want to store, go to simulation, you can use this scene capture option, save the current scene or copy to clipboard or export as a 2D image, whatever you want you can do it. And this contour also, see now it is velocity, you can change to pressure and other values also. You see simulation is going on, it's going to end. So instantaneous also you can see how it is varied. So So it is going towards around 1.17 for 10 degree. So it is updated. After that it is just a constant line. So it is stopped and updated from 0.52 to 1.18. From 0.02 to 0.08 it is increased. If you want further, you can increase the angle of attack. Maybe same design, move, select the airfoil, rotate it. Maybe this time I can give 20 degree. That means 340 I have to give once the window opened. Window is coming. So 340 you enter. So 20 degree and all. It is a stalling angle. Flow will be completely unsteady. So as I mentioned, even after 5 degree itself, you can go for the unsteady time dependent study. You can do it. Okay. Just by pressing this, you can convert steady flow to unsteady flow. Okay. And see, for this unsteady, if you see the instantaneous force, you can see there will be fluctuations, but this fluctuation also it will become constant. That is, and the maximum minimum mean line, if you draw, it will be like a constant. Once it is reaching the constant, now the solution will stop and that mean value will be recorded here. So press escape to clear that unwanted window, etc. and all. You see the mean line may be just a constant. It is around 1.08. Okay, so because 20 degree means stalling, so it is reduced and drag is increased to maximum. Like that you can change the angle and you can get the data continuously here. Even you can export this data. So you export all chart or export this chart alone, means same data will be stored as a Excel file. So this is how you have to save the CLCD value. You can save the plot, etc. So this is messless design. Easily you can do it. Maybe for some initial study it will be very good, but you should have the Quadro graphics card. Otherwise it won't work. Yeah, that's it. One more thing, that if it is mainly for 3D. Okay, just I tried the 2.5D. Okay, just press the center scroll button and move. You can rotate the object. So this is just a 2.5D, and 3D means your domain will be bigger. It will take more GPU memory. Okay, so maybe next time I will show you the 3D model simulation.